Section 9.4 is on ellipses. The definition of an ellipse is the set of all points in a plane such that the sum of the distances from two given points, and those points are called the foci, is constant. Here's a little bit of a video that I found on YouTube that'll illustrate that. So you'll notice that the red line and the blue line are making their way around the ellipse, and an ellipse is just an egg shape. And the 2 points that those lines are coming from are the foci. And if you were to add up the length of the red line and the blue line, it would stay the same no matter where the line is. So that's kind of the formal definition of an ellipse. Now, the standard form of the equation of ellipse is given by this: x minus h squared over a squared plus y minus k squared over b squared equals 1. And some of this x minus h and the y minus k business probably looks very familiar. But this is the first conic section we've seen that actually has a denominator, has a fraction with a number in the denominator, and it always equals 1. For the matter of this video, we're just going to focus on ellipses that are oriented kind of horizontally, that look a little bit more like an egg laying on its side. That is, they're longer in the horizontal direction. You can have an ellipse that's more vertical, going up and down more, but we're just going to focus on this for now. The center of the ellipse is going to be at the point HK, and the foci are going to be at the point H plus or minus C, comma K, where C squared equals A squared minus B squared. So in other words, you're going to take H and add C to it to get one x coordinate, and then subtract C from it to get the other x coordinate, and the y coordinate is your k. We're actually not going to focus too much on the foci. The length of the major axis, and that's a horizontal line that goes through the center, is going to be 2 times whatever a is. The length of the minor axis, which is going to be a vertical line that goes through the center, is going to be 2 times b. And the vertices, which are the end points of the major axis, are going to be at h plus or minus a, comma k. And the co-vertices, or the endpoints of the minor axis, are going to be at the point h plus or minus, h, comma, k plus or minus b. And actually, that you don't have to memorize those. We're going to graph it, and you'll see how it works out. So let's take a look at a couple examples here. For each ellipse, we need to write the equation in standard form if necessary. We're going to identify the center, the lengths of the major and minor axes, the vertices and the co-vertices, and then graph. So the first thing I'd like to do is identify my h, my k, and my a, and my b. So looking at this equation, purple, my h is 2, my k is negative 3. So that's going to give me my vertex. Oops. Sorry about that. I want to make this a little wider here. So my vertex, my center, my center is going to be at the point 2, comma, negative 3. And actually, maybe I'll just go ahead and graph that right now. Okay, so 2, negative 3 is my center. And looking back at my equation here, 25 is a squared, so a is going to be equal to 5. And 16, this right here, is b squared, so b is going to be equal to 4. So that means that the length of my major axis is 2 times a, or 10, and the length of my minor axis is 2 times b, or 8. And before we find the vertices and co-vertices, let's go ahead and just continue graphing this. So I know this is going to be basically oriented horizontally. My major axis is 10 units long, so from my center, I'll go 5 to the right, and 5 to the left, and that's my major axis. That's 10 units long. My minor axis is going to be a total of 8 units, so I'm going to go up 4 and down 4, okay? And I'll sketch that out. Try not to make it look too pointy on the ends. Try to make it look a little curved. That's not wonderful, but that'll do okay. And now my vertices are these 2 points at the end of the major axis. So I have vertices at the point 7, -3, and at the point -3, -3. And then my co-vertices are the end points of the minor axis. And that would be the point 2, 1, and the point 2, -7. And I think that's everything we needed to do. So basically, once you identify H and K, that's going to give you your center. Identify A and B, and that'll give you the length of your major and minor axes. And it'll also help you to graph it, because that's how many, for A, that's how many units you'll go in each direction from the center. For B, that's how many units you'll go up and down from the center. And then you don't really have to memorize these formulas here for the vertices and the co-vertices. As long as you know how to graph it, you can just read the points off of the graph. Our second example is a little more complicated because this is not in standard form. This is in general form. And we saw this when we were dealing with the equation of a circle and a parabola as well. So I need to do that little trick of completing the square. So the first thing I'm going to do is separate it out a little bit, put my x's together. Sorry about that. And I need to put my y's together. And I need to move my constant to the other side. Now, in order to complete the square, I need to get rid of the coefficient in front of x squared. So I'm going to factor out a 9, and I also have to factor that out of the 72. And I have to factor out a 25. And I also have to factor that out of the 150. So that's going to leave me with 6y. Okay. And now to complete the square. If you remember how to do that, I take half of b and square it. So that means I'm going to be adding 16 here. Okay, but I didn't actually add just a 16. I really added 16 times this 9 over here, which is 144. And to complete the square with my y's, I need to take half of b and square it. So that's going to be plus 9. But I didn't really just add a 9. I really added 25 times 9, which is 225. So now I can clean this up a little bit. So this is going to be 9 times x plus 4 squared plus 25 times y minus 3 squared equals 225. But you'll notice that the standard form of an ellipse actually has a 1 over here. It equals 1. So I'm going to divide everything by 225. And actually, for a lot of these, a kind of cool thing works out. 9 over 225 leaves me with a 25 on the bottom. 25 over 225 leaves me with a 9. I'm sorry, this one's going to leave me with a 25 on the bottom. This will leave me with a 9 on the bottom. So your final equation will look like this. X plus 4 squared over 25 plus y minus 3 squared over 9 equals 1. And that's standard form of for the equation of this ellipse. So let's identify some of our parts. So my h is going to be -4. My k is a +3. A is going to be 5 and B is 3. Remember, this 25 is A squared, so A is going to be 5. 9 is B squared, so B is going to be 3. So let's go ahead and graph what we can here. So my center is going to be at the point -4, 3. So -4, 3. And maybe I'll write that over here. Okay. And my major axis is going to be 10, and my minor axis is going to be 6. Okay, and I will use my A to go 5 units to the left and right, and my B to go 3 units up and down. So 5 units to the right, 5 units to the left. That's my major axis of 10, and then 3 units up and 3 units down. And I'll sketch my ellipse. And now it's very easy to identify my vertices and covertices. So my vertices are at the point 1, 3, and at the point -8, 3. Is that right? Oh, wait a minute. No, not -8. That's -9, I believe. 4, no, I'm sorry, -9, 3. And then my covertices are at the point -4, that's 6, and -4, 0. So, in order to find out all of this information regarding an ellipse, writing the equation in standard form, identifying the center, the major and minor axes, the vertices, and the covertices, the easiest way to do it is you do have to write it in standard form as we did here, which involves completing the square. Identify your H and your K and your A and your B. HK is going to be your center, and A and B are going to tell you how far from the center you need to move left and right for A, up and down for B. Makes it very easy to graph, kind of as we did with a circle. And then it's very easy to identify your vertices, which are going to be on the longer, the major axis, and your covertices, which are going to be on the shorter or the minor axis.